In this video, we're going to take a look at some applications of exponential functions. So you may notice that the sheet is already filled out. That's because this is now my second time recording this video. I already filled it out the first time, but then there was a problem with the video and it couldn't be uploaded. So our question here says, during a science experiment, the mass of a petri dish containing bacteria is shown by the equation below, where m at t is the mass in milligrams and t is the time in hours since the start of the experiment. So I have m at t equals 3 times and then 2 to the power of t over 3 plus 100. And it asks us to graph the function using transformations. So base function, when I'm looking for the base function, I look for anything that is not a number. And the only thing here that's not a number is that t, but that t is in an exponent. And an exponent can't exist by itself. It needs to have a base. So the base that would be attached to it is 2. So this is 2 to the power of t. So that's what I chose as my base function. Now I originally had put x and y in the table. I changed that to t and m to match the letters, but you could also leave it as x and y. So for my 2 to the power of t, I did all the numbers from -4 to +4. And then I calculated by doing 2 to the power of each of those numbers. So 2 to the power of -4, the negative exponent makes it a fraction, so I did 1 over, and then 2 to the power of 4 was 16. Then I did 2 to the power of -3, that negative exponent made it a fraction, so I wrote 1 over, and then 2 to the power of 3 is 8, and then I continued doing that to get 1/4, 1/2, 1, 2, 4, 8, and 16. All right, for the transformations, there's a 3. There's a 3 on the denominator there, and then we have 100. So the 3 in front is in the A position, so that is a vertical stretch of 3. Vertical is y, or in this case m, so I took the m and I multiplied it by 3. This 3 in the denominator under the t, I could write t over 3 as 1/3 t. So that 1/3 looks like a compression, but it's actually a stretch when it's inside the exponent. So that is a horizontal stretch of 3. So to my x's, or in this case t, I multiplied by 3. And then the last part, the plus 100, is not in the exponent, it's after. So this is going to be my up and down. This is going up 100. That changes the y value, or in this case m, so I added 100 onto my m values. And then all I did was I took my calculator, I took all of the t values from the base function and multiplied them by 3. To get -12, -9, -6, -3, 0, 3, 6, 9, and 12. And then I took all of the m values, used my calculator to take each number, multiply it by 3, and add 100 to get all of those numbers there. All right, I plotted those numbers. I started with the non-decimals, so 12 and 148. You'll notice on the y-axis the scale is not going up by ones, it's actually going up by tens. So I had to estimate where some of these numbers were. So I had 12 and 148. I had 9 and 124. We had 6 and 112, 3 and 106, 0 and 103, -3 and 101.5, -6 and 100.75, -9 and 100.38, and then -12 and 100.19. So I did notice that we were getting very close to 100. We also have plus 100 in the equation, which tells me there's a horizontal asymptote at 100, so I drew that in. And then I found that my last point was here, and there was quite a bit of empty space where there probably could have been another point. So what I chose to do was, this was the last point in my table. I decided to do another point after that. So I added 5, I calculated 2 to the 5 to get 32, and then I took my 5, I times it by 3, I took the 32, I multiplied by 3 and added 100, and I just got an extra point at 15 and 196. So sometimes when we're doing the transformations and we're compressing or we're shifting things, we end up with numbers like big areas on our graph where we don't have points. So if you ever have that, just add another point. Sometimes I might add 2 extra points, but here I only just added the 1 just to get a better shape on that graph. Okay. If you need to freeze the screen, please do so. I paused the video, but I'm going to move on and talk about part B. So part B says, state the interval on which the mass is less than 200 milligrams. So I actually started with the graph. So I went to look and see where 200 milligrams was. So 200 milligrams was here, and then I followed it across to see where my graph was. I had a point that was really close. This is the one at 15 and 196. So I'm really close here. It's a little bit bigger than 15. I'm just not sure exactly what. Because I wanted it less than, I was interested in everything below 200, but it didn't say equal to. So I would either have said less than or equal to 200, or where the mass is 200 milligrams or less would be what it was if I actually wanted to include that point. But it just said less than, so I did an empty circle, and then I colored in everything below 200. Okay, so when I go to do this, if I'm just looking at the curve, we are looking at all the x values between negative infinity and whatever that point is there. Which I can tell now is 15.18, but we hadn't calculated that yet. However, when I'm doing this, this is an application question. So it's not just about looking at the graph. You need to think about the context of the question. So it says t, which is my x-axis, is the time in hours since the start of the experiment. So the experiment would have started at 0, right? And anything before that, like -1, -2, -3, -3 would be 3 hours before they started the experiment. So those values don't make sense. So you'll notice I had put a big X through this side of the graph, and that's because when I go to state my inequality, it doesn't make sense to use any time values before 0. The other part here on the other end is that I don't know what this value is. We had to calculate it. So I did that by setting m at t equal to 200 to see where that point would be. So I ended up with 3 times 2 to the t over 3 plus 100 equals 200. I subtracted 100 from both sides. I divided by 3, which did not work out evenly, so I left it as a fraction. To move a power with a base of 2 to the other side, I would do a log with a base of 2, and then I multiplied by 3. And then I had to use change of base in order to calculate this. I like ln, you could use log. So I did ln of 100 over 3, and then I had to divide by ln of what was our old base, which was ln 2. And I ended up getting 15.18 as our time. So technically, if I was looking at it from a mathematical perspective, it looks like it's between negative infinity and 15.18. However, the negative infinity doesn't make sense in terms of the time. The time would have started at 0 and continued until it hit that 200 milligrams, which is at 15.18. So the 0, we did actually have that amount in there at 0, less than 200, so I would include it, so I did a square bracket. And then the 15.18, because we didn't want it to be equal to 200, we just wanted less than 200, that's why I did a rounded bracket there. So the interval for that section that makes sense for this question would be between 0 hours, I believe, and 15.18 hours. Okay? There are practice questions for you to work on. Have a great rest of your day.